All right, good day and welcome back to Everything Mathematics. And today, again, we're going to continue our series on compound shapes. And the shape that we're going to be looking at today is right there, that T-looking shape. Yesterday's video, not yesterday's, in the last video that I would have done, I would have given you the concept as to how we could go about solving compound shapes. Usually when given a compound shape, is either one of two things they ask us to do, right? Is either they ask us to find the area, they ask us to find the perimeter, and again, on and off, sometimes you could do some algebra there too. They could ask us to find some missing side or some missing length or what's not. Anything is really possible, but those are about the common things they ask. So here, as I expressed in the last video, how do we go about solving this? Or how do we go about finding the area? Simply comes down to how we decide to dissect the shape. So I will take this approach. You have the easy way, you have the hard way. I mean, I don't know. There's no such thing as easy or hard when you really know how to do it, right? But let's say the simpler approach may have been to simply divide this shape like this. And if you divide that shape like this, notice that you would end up practically with a rectangle at the top and a rectangle at the bottom. That's basically what you're doing. And remember, as I said yesterday, you have to be able, I keep saying yesterday, as I said in the last video, you have to be able now to determine which side or which dimension belongs to who. So how do we do that? We could clearly see that this 11 would have fallen on top yesterday. So this long side here is still 11 meters, right? This side here, which was 7, would associate with this side here, that would be 7. Good. Then you might ask, what is this side here? Well, this side is evidently this side here. So this side here would have been 6 meters. And the only side we don't really know here is this side here. Let's label it as 8. But we could find it. If we look at the vertical distance, the overall vertical distance is 11. Out of that overall, we know that this piece here is 3, and we know that this piece here is 4. So if we want to know what's the missing piece, it would be 3 plus 4, that's 7, and we take away that 7 from 11. And that means that this missing piece here would also be 4. 4 plus 4 is 8, plus 3, 11. So yes, this could definitely work, right? So this piece here would be 4. And once we have that, then it's a matter of just finding your areas. We have 2 rectangles here, and the areas of rectangles is basically length by width. So here we would have 11 by 7, and below here we would have 6 by 4. So the area of one, I usually like to label them. Sometimes I label one shape as A, the other shape as B. It's not a must, it's up to you. But technically we have 2 areas here. So we have area 1 plus area 2 would give us area T. And when I say area T here, I'm talking about total area, right? So area 1, supposing this one here is area 1, the area of 1 is 77. Good? Plus, well, meters cubed. And the area 2, in this case, would be 24. So what is our total area? When we put 73, 77, and 24 together, we should get what? 4 and 7 is 11. So I have 1 here, 9 and 2 right there. So that's supposed to be 10. So 101. Let me just make sure. 7 and 4, that's 11. So I have 11. I cross away my 1, put it there. And then you have 7 and 2, that's 9. Plus that 1 from the 11, that will make it 10. Yes, so that's correct. So in essence, our area here would be 101 meters squared. And that's it. That's it. We just break it up. We dissect the shape. We, we cut up our shapes. We find associated lengths, and we do our geometry. We do our arithmetics there, right? So the area of this entire T here, total surface area that is, would be 101, and I trust that was clear. Now let's go on to the perimeter. For the perimeter, we need the distance around the shape, right? And as I established yesterday, the best way to approach this is by counting how many sides the shape has. So let's count. Starting from the side with 11 here, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sides. That means this is an octagon. How do I find the perimeter? I need to add 8 sides. Do we have 8 numbers? Do we have 8 dimensions? No. We have 1, 2, 3, 4, 5. So we're missing 3. Let's find out what are the other 3. And the other 3s are deducible. deducible. So here we already established that here would be 4 meters. I trust you understand how we got that. We just added up the vertical distances. Good. If here is 6, over here will also be 6 meters. That's properties of rectangles. Opposite sides are parallel and equal. And what again we're missing? This side over here, again, properties of rectangle. Opposite sides are parallel and equal. So if here is 7, over here would be 7 too. And mind you, I think this is key information. Even though the shape is not drawn to scale, as they would often say or often tell you, that does not take away the fact that the properties of the shape are still standing. So yes, I might draw a rectangle and I tell you that the rectangle is not drawn to scale. All that is telling you is that the measurement of the rectangle is not authentic, but the characteristics and the properties will still be authentic, so long as they tell you that it is a rectangle. So please take note of that. That's important. So yes, it's not drawn to scale. We'll simply tell you 11 centimeters is not really 11 centimeters. But not drawn to scale also tells you if here is 11 centimeters, then we have to assume that the other side is also 11 centimeters. That is fair. And that's what that's why we need to know the properties, the characteristics of the various shapes, because not drawn to scale does not take away that fact. You remember that? Good. So here we have everything we need now. We have 8 sides and we have 8 dimensions. So from here is just to do our arithmetics. So we start from 11. So it's 11 plus 7 plus 4 plus 6 plus 4 plus 6. Where was I? I think 6. I do 4. I do 6. So 3 plus 3 plus 7. Good. And if I just add, let me just count them to make sure I have 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And now I could just add them. If I add all these, I get my perimeter. So let's see how I could break this down. If I group these 2, I'm getting 10. If I group these 2, I'm getting 10 again. Oh, look at that. If I group these 2, I'm getting 10. Oh, that's how easy that makes my life. So 10 plus 10 plus 10, that is 30, 30. And this 2 gives me 18. So 30 plus 18 is 48. 48 meters. That's my perimeter. Very well. So yes, that's how we handle compound shapes. And again, this is just example number 2. And I think I will wrap up with that for today. So again, just remember, any compound shape you get, break it up. Break it up. Break it up into smaller rectangles, break it up into squares. You could break it up into circles. You could break it up into triangles based on what is given. And then you just work that separate part by itself. And then you have to remember it was a compound shape. So you have to bring it back together to get your total thing, right? So that will be the end of today's session. So as always, feel free to like, share, subscribe, and leave a question in the comment section. Maybe if there's anything that wasn't clear. And as usual, look out for the next one. Until then.